Hello and welcome. So today we'll be talking about this chapter 2, which is the computing components. So last week we talked about a little bit recap. We talked about what is IT. So of course we define IT itself is information technology. We talk about what is the evolution, right? The evolution of IT, and finally, we'll talk about the importance of IT to accounting, and finally, we talk about the changes in the accountant's role with the IT in place. So this week we talk about the components, the computing components. In simple word, we actually look into what is inside a computer. Most of you have already known this very well. In fact, maybe you have already started building your own computer, right? You already start building your own computer, and if you already did that, means you're good as it is. So an introduction is what is inside a computer. We'll find ourselves with the CPU, which is the central processing unit, the brain of the computer. This CPU is usually attached with the motherboard. And this motherboard usually attached with the RAM, random access memory, attached with the storage, nowadays we use the SSD. As those days we use the hard drive, right? Then we attach the power supply to this. But there's another thing over here. There's actually a ROM that is built inside the motherboard. We'll talk about these points over here. Let me see. Of course, to power up all of this, alright, we need a power supply unit. Okay, so this is basically the components inside a computer. Let me think. Of course, we got if we talk about some higher level computer, then we got the GPU, graphic processing unit, the GPU, and what more we have? Maybe the ROM, the DVD ROM, and the CD-ROM. The USB ports actually attached with this one, with the motherboard. What we have, floppy disk. That was those days, but on a general aspect, this is what is inside the computer. This is what I say, a typical computer, not the mini computer or the all-in-one computer. I think some of them is soldered together. It means they have been molded together into one piece of chipboard. And a good example is inside the laptop. Sometimes laptop, the RAM or the storage are soldered together with the motherboard. And yeah, that's the starting point. So of course this is the simple part of this, or the general overview. So we look into detail on how these parts contribute or would formed up the computing components. Yeah, like how this actually work, right? Let me just how a computer compute, right? How a computer compute, a big question mark. So that's why we want to learn a bit, I would say, a very basic, general, just very basic idea on how a computer compute. Of course, this is not hardcore computer science topic that I would like to go into that level. I'm not even qualified to talk about that part because it's really complex, and it itself, it's a syllabus by itself, right? It's a subject by itself, how a computer compute. But knowing the basic idea behind how a computer thinks, or how a computer not thinks, how a computer compute is a correct word. Yeah, how the computer compute. So first of all, we need to know that computer and we human think, count differently, right? We count different, we count differently. Okay, we count differently. So we use the decimal. Say system. All right, this is us. Well, the computer use the binary system. Simple as that, right? How we count decimal, the computer count binary. This is the first of the foremost concept that you must accept. What is decimal? What is binary? Now that's a good question. Decimal basically is 0 to 9. 1, like 0 to 9. But binary over here means 1 and 2. 0 and 1, alright? 0 and 1 only. So for example, go 1, 2, this is okay. We'll go 1, 2, 3. Let me just go like this. And let me just go. Okay. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Can you see that? So how computer compute, right? They will just think 1 or 0, and 1 and 0 over here is basically we name them bit, right? We call them bit. This is bit. So 1 or 0. We name these digits, we call them bit. And a collection of 8 bits, alright? So bit is basically single. Binary digit. Okay, single binary digit, but bytes, YTS, is 8 bits. Okay. So in bits is either 1 or 0. Bytes is maybe 1, 2, 3, 4, 5, 6, 7, 8. Okay, something like this. This is bytes. Okay, 8 bits equals to 1 byte. Then of course when you talk about this, you got the megabyte. No, you go with kilobyte first, megabyte, gigabyte, terabyte, and so on. All right, it increased. Okay, now we go back to here. This is how we count. We count 0 to 9, but the computer count by bytes. All right, they cannot think. That's the reason why they can count. They only count by bytes. Basically, if 1, it means there's electric input, and if 0, this is yes, and this is no. All right, no electric input, then it will become 0. If there's electric input, it became 1. So come back to here, how they count. They count by 0 and 1. So we go from 0 to 1. So this computer, how they calculate goes like this. All right, very interesting. It will start with 0 0 0 0 0 0 0. All right, 1 2 3 4 5 6 7 1. All right, then when they go 2, it will become something like this. All right, and then 3, 4, 5, 6, 7, 8, and 9. Yeah, this is how the computer will, because it's secure, right? Later we'll talk about a bit on how this electric input is then in a circuit, how the circuit can be connected in a way when we input this, the computer will compute accordingly. However, we're not going to that detail, we just touch and go, but the logic is something like this. All right, the logic is something like this. This is the basic computation of how a computer count. How a computer count compared to us. If you want to go into detail, we can look at the operations, right? What they call here is the logic gates. So here, logic gates. This is the evolution thing. With the logic gates, we can do a lot of things. We can compute, we can sum up, we can instruct the computer to sum, to deduct, and so on. All right, multiply and divide. Logic gates is basically it is used to do complex computation, and it can also use to when logic gates, there are simple logic gates like the AND OR. I think these are simple logic gates. Most of you should know this one. If you got two input, right, you got the truth table. These are all inside the notes that I will share later, but I'm just going through with you. There's input, or this is the electric input, right? The electric input over here. Electric input A and B. Okay. The output. So if for N, right, one, there's electric input here and no electric input for B, the output will be 0. Basically the AND gate should be something like this. All right, if you look from the circuit board, go like this. All right, should go like this. Don't want to show you this one, it will further confuse you, but never mind. 0 1 it became 0, 1 1 it became 1, 0 0 became 0. And means A and B. If there's electric input, then it will come out with the output, right? I don't want to waste so much time. It's just to show you the idea behind this, not to confuse you any further. If 1 0 it's 1, 0 1 is 1, 1 1 is 1, 0 0 is 0. Okay, this will actually either one have the electric input, then it will consider the input available. That's pretty much the simple logic gate. So what happened is, this simple logic gate, these are the binary input and output, right? It's only look at the very basic bit. All right, it's only like 1 or 2 bit. In complex gate, there is like a millions, or not millions, like a few simple basic gates that will be combined. There's of course a lot of different combination, which we're not going to go into depth of all of this thing. We're not learning them anyway, but I just want to let you know that this gates over here will form a complex combination. That's how it would form these codes over here. And when you input certain code, all right, when you input through, let's say, a calculator or through the keyboard, the system will recognize certain sequence over here, and it will compute accordingly. It will not compute, it will process accordingly first. Then when they go through the CPU or the processing unit, then it will compute when you instruct the CPU to do so, right? In the notes, I have a very detailed, not very detailed, but like more detailed explanation on how these simple logic gates can form a complex logic gate to actually store, compute these frequencies. All right, and then if you are interested, you can see how the computer process, all right, how the clock will triggers the speed on computation. That's a clock, all right, it's like a clock. So is that clock, how it will be faster if you adjust it accordingly. All right, don't talk much about that. Basically, I didn't go through at all. I want to the last part before I go into the CPU is how to calculate how the CPU, or how the computer will compute by using this one. All right, let's say 2 plus 3 is equals to 5, right? So if you can see over here, let's take away the 4. 2 is over here. 1, 2, 3, 6 plus 3 is okay. This is how the computer compute. All right, simple arithmetic over here. They will have this what they call the carrier. All right, this one 0 plus 1, the sum over here is 1. Carry, right? There's a carry over here. So 1 plus 1 is equals to 0, but there's a carry 1 over here. Then it became 1. Of course, all of this is 0, 0, 0. Okay. So if you can see, this actually match back to this one over here. Can you see that? Okay. Of course, that's how you input. There will be like a flip-flop gate, or depending on what they call this, the full adder. circuit, right? Full adder circuit where there's a input in this two, and then when you sum up, then there is a carry. It will have the output of this amount. Okay, this is how the computer compute, of course through the CPU, that we'll talk about it later on here. So far that's it for this part over here.